Hello and welcome to ashford.com. You are watching an interesting video on Alzheimer's disease. The brain has a way of compensating for damage by recruiting extra brain circuits. Please read this disclaimer carefully. One of the hallmarks of Alzheimer's disease, the most common form of dementia, is the buildup of beta-amyloid protein deposits in the brain. Now, a new study published in the journal Nature Neuroscience suggests that in some older people, the brain has a way of compensating for this damage by recruiting extra brain circuits. Previous studies of scans have shown that some older adults with Alzheimer's damage who retain thinking and memory capacity show signs of extra brain activation. But until this study, it was not clear whether this extra activation is linked to better mental performance or if the extra activation is abnormal overexcitement. William J. Gust, a professor in public health and neuroscience at the University of California, Berkeley, says they found the aging brain can compensate for beta-amyloid damage. He says it is still not clear, though, why some older people with beta-amyloid deposits are better at using different parts of their brain than others. Stimulating mental activity may help brain remain adaptable to damage. However, in a previous study, he and his colleagues found that lifelong active brains have less Alzheimer's protein, so he suggests, "I think it's very possible that people who spend a lifetime involved in cognitively stimulating activity have brains that are better able to adapt to potential damage." Alzheimer's disease accounts for 60 to 80% of cases of dementia, a general term for conditions that impair memory and mental ability so much that daily life becomes very difficult. According to the Alzheimer's Association, every 67 seconds, someone in the United States develops the disease. The direct cost to the nation of caring for people with Alzheimer's will total an estimated $214 billion in 2014, including $150 billion in costs to Medicare and Medicaid. Alzheimer's disease has two hallmarks: deposits of beta-amyloid protein that build up in the spaces between nerve cells, and tangles or twisted fibers of another protein called tau that build up inside cells. Evidence that the aging brain can compensate for presence of Alzheimer's proteins. For their study, Professor J. Gust and colleagues examined functional magnetic resonance imaging brain scans of 71 participants as they performed mental tasks. The participants were 22 healthy young adults and 49 older adults with no signs of mental decline. Shown are scans that represent all subjects with beta-amyloid deposits in their brain. The yellow and orange colors show areas where greater brain activation was associated with the formation of more detailed memories. The brain scans revealed 16 of the older participants had beta-amyloid deposits, and the others did not. For the mental tasks, the researchers asked the participants to memorize pictures of various scenes. Afterwards, they tested their ability to remember the gist, and then the details, of what they had seen. For example, one of the pictures showed a boy doing a handstand. To recall the gist, participants were asked whether a general description of a boy doing a handstand corresponded to the picture. Then they were asked to confirm whether more specific details, such as the color of the boy's shirt, were correct. Professor J. Gust says both the groups performed the tasks equally well, but it turned out that for people with beta-amyloid deposits in the brain, the more detailed and complex their memory, the more brain activity there was. It seems that their brain has found a way to compensate for the presence of the proteins associated with Alzheimer's, he adds. Funds from the National Institute on Aging and the McKnight Foundation helped finance the study. Recently, a team led by Washington University in St. Louis, Mo., suggested that late and early onset Alzheimer's are similar in the way they affect brain function. References: